So the Bohr model of the atom was great because it helped to explain why it is hydrogen gave off those colors of light, suggesting that it was quantized and everything was building on itself really nice. It helped to predict the frequencies and the wavelengths and the energies and all kinds of stuff. But what the Bohr model did not do was do a good job explaining how atoms are put together for atoms that have more than one electron. And obviously the one with one electron is hydrogen. And as soon as you started getting to 2, 3, 4, 5 different electrons, 100 different electrons, everything just started falling apart. Obviously what that means is even though the atom is quantized and his model helped to explain things, there must be more to it. And so more ideas needed to be developed to help out the idea. And so two new ideas came up to help to explain this and to not so much explain, but to help the models out. And the first experiment or next idea that came about, not that he wasn't an experimentalist, he was a Louis de Broglie was a theoretician. He came up with ideas. He was a theory guy. He didn't do experiments. He came up with a mathematical relationship and justification suggesting that photons, when they move around like a wave. He suggested that not only is it that the photons move around like a wave, but atoms, electrons themselves move around like waves. And so instead of being orbits, he suggested that they kind of wiggled around like a snake around. And so the photons had wave-like properties because the electrons themselves had wave-like properties. And so that idea was messed around with and so on and so forth. But it wasn't until a couple of years later where an Austrian physicist whose name was called Erwin Schrödinger developed a set of equations that describe the energy of an electron as both a wave and a particle. Because usually you think of an electron as just a particle. I mean, that's like a little ball of charge going. He said that the electron moves around like a wave too, like a particle and a wave. And so his equation was so helpful that it helped to describe the electrons in the atom of not just hydrogen, but just about every atom that you could think about. And not only that, but the entire electromagnetic spectrum as well. Now, his equations that he came up with were crazy stuff. And I say this as a chemist as well. I had to study these things when I was in school. Physicists have to study these things when they're in school. But here's the equation. Just want to show you one example. And it uses high levels of mathematics, no, we're not even going there. But I just want to show you what it looks like. Okay, so if this is like a squiggly thing, it looks like a squiggly thing. But it has partial derivatives and so on and so forth. This is beyond calculus by a lot. But anyway, we're not going to go there. I just want to show you what it looked like. But his work and de Broglie's work and Bohr's work and everything put together caused physicists in particular to think about how it is that matter is put together in a new way that actually sparked a new area of physics called quantum mechanics, a whole new branch of physics. And that area has exploded into a whole new realm of stuff. And without quantum mechanics, you wouldn't have technology, you wouldn't have things like computers, you wouldn't have lasers, you wouldn't have any things that you have today if it weren't for quantum mechanics. So what you end up with is a much more complicated way of thinking about the atom. And we're not going to go there. But what I'd like to do is give you some of the big highlights of what it does. And so we end up with a model of the atom that gives an atom this general appearance. It gives an atom a quantized nature that behaves characteristics like a wave, like a particle. It's quantized. And you can kind of see it. You can see sort of like this quantized level within it, like the little mini orbits, but it's not perfect. It's not exact orbits. I like to think of atoms as fuzzy spheres because it looks like a fuzzy sphere. And so what we need to do is to talk about this fuzzy sphere that we now think about atoms being, and we'll do that in our next video.